is StarTalk. I'm your host, Neil deGrasse Tyson, your personal astrophysicist. And I got with me, as always, Chuck Nice. Chuck.
Hey, Neil.
So we are live.
Live. Oh, my God. Wait.
What does that mean?
It means I get to hold up a newspaper and it will have today's date on it.
You still read newspapers? What is that? Your news comes to you in paper?
Wait a minute. It means I get to hold up my tablet.
You can hold it there. Hey, no, here we go. It's a, yeah, there it goes. 6:38, and on the cell phone.
Right? Look at that.
That should do it.
That shows that we're live. I feel like. Okay, and now we have to give them. Now we have to give them proof of life so that we can get the money for our victim.
No, stop. So anyway, why are we doing this?
Yes.
YouTube Live.
Yes.
It's to sort of celebrate the fact that I got a YouTube present in the mail.
Finally, are we going to get to see what's in that thing finally?
I think so. Okay. Yes, we're going to open it up. But also I just want to say thank you to our Patreon members. These are people who basically actively subscribe to us by giving us money each month. This is a higher level of participation.
That's right.
And we do things for them, exclusive things for them. Like they get their own cosmic queries, for example. And there are other things. There's like a scale depending on how much you put in, and becomes a fundamental buoyant force in what we do to bring this show to you. And also, I think some people don't know that we have this sort of topical spinoff of StarTalk called StarTalk Sports Edition.
That's right.
And you're my co-host with Gary O'Reilly.
That's right.
Who's
former footballer.
Footballer translate that, Chuck.
That's a professional soccer player across the Great Pond. He played for Crystal Palace and Tottenham Hotspur.
Okay, very, very good. And so we realized that there's a lot of science in sports and a lot of actual athletes and coaches and trainers, and all of what goes on in sports is such a big part of modern life, social life, really, that we felt it deserved its own sort of path within the StarTalk universe. So StarTalk Sports Edition is there. So you can check that out. But anyway, I want to open this. Can I open this now?
Please. Let us see. Okay.
Here we go. Oh, so here's what happens. So if you have a YouTube channel, as we do, StarTalk channel, when you hit these milestones, these are milestones in base 10. Okay. So 10 to a power of some number. So if you hit 10,000, 100,000, and we recently hit 1 million.
Hit the million.
1 million.
So what do you get? What do you get when you hit 1 million?
I don't know. Let's see.
Looks heavy.
Ooh.
Well, you get a black piece of paper. Wow. Oh my God, that's amazing. YouTube, you're too kind.
Whoa. Can we see that?
Oh, that's really pretty.
Yeah.
Oh, look at that.
Has that been focused?
I can see it. I can see it.
So I'll read it to you. It says, presented to StarTalk for passing 1 million subscribers. And you press this, but nothing happened.
And there you go. I was going to say. Just you press that and you have 1 million subscribers, and
that's all it takes.
That's all it takes.
You just press it.
You just press that button. You get a. Oh, that's very cool, though.
Yeah. So we'll find a place to hang this, and so next target, I guess, would be 10 million.
10 million. There you go.
Maybe
power of the 10. So maybe you could put that right next to your coronavirus containment field that you have sitting behind you.
Chuck, you're not supposed to.
It's like you got
what field? What? Huh? What?
That's a very cool looking. That's a cool looking thing, but it looks like the coronavirus in a like some kind of like electromagnetic containment field.
I am not authorized to say anything further about that device.
Oh, right on. Okay.
Just saying.
Right. Yeah.
Just saying.
As long as you're not coming to us from Wuhan, I think I'm okay.
I'm in an undisclosed safe house.
Okay.
in the middle of nature, hence the beetles and other things that surround me.
Yeah.
So anyhow, so we're gonna do what we do best and take some questions from the audience. Some have already rolled in, and then we can take some live since this is live.
No, I might as well.
And you've got it all. I haven't seen any of them, Chuck.
Yeah, and it's funny. I love it because I lifted them right off of the YouTube site, as you can see, and they say like 18 hours ago, 12 hours ago. It's kind of cool.
Yeah, cool. When they arrived, yes.
Yeah, right from when it arrived. So this is Snack Dealer 1. He says, if a separate human colony was well established on Mars, what would likely be the most valuable resource Mars could trade with Earth? Ooh, so kind of reminiscent of a television series called The Expanse, except it's not Mars. The humans that move to Mars become far more advanced because they're all like real sciencey minded. And then the ones left on Earth are just like, Trump supporters. No, I'm joking. I'm joking. That was a joke. The ones left on Earth, they continued on in the path that we Earthlings could have, the trajectory that we're on. But then there's a separate group of Earthlings that go out to the Kuiper Belt, and they're miners. And so they're actually bringing all the good stuff out of mining these asteroids. And it's funny because the three of them together have like commerce. Yeah. And so when he says this, I immediately thought of that if there was a Mars Earth 2, how interesting would it be? Would Mars have something to give to us?
Okay, so first of all, the Kuiper Belt has mostly icy objects, icy bodies, and which is much less use to us than heavy metals. So and the asteroid belt is way closer than the Kuiper Belt. So whatever.
I'm sorry. It is the asteroid belt. I'm sorry. I said Kuiper Belt. I meant to say asteroid belt.
Fine. Don't get me started.
Yeah, that's my fault.
In your situation.
Yeah, Don't blame the writers of The Expanse on that.
Okay.
That was me. That was my slip up in words. They're not in the Kuiper Belt. They're in the asteroid belt, hence the mining operations, because they're grabbing these large, craggy, floating boulders and drilling down into them and pulling out all kinds of good stuff.
Okay, so here's the thing. We don't yet know the full depth profile of Mars and what it contains and what's there. There's probably not oil deposits, I'm guessing. Oil on Earth comes from dead vegetation from millions of years ago. So no, but that's what discovery is all about, right? But who knew that Earth had oil that you could pull out of the ground and build civilization on it and then have to get rid of it later, right? So you just don't know. You just don't. That's the whole point of exploration. So Mars, it would be interesting. What I can imagine is you can have inventive people there that use the natural resources that are common on the surface of Mars and do something inventive with that and then trade that. And that way, so it wouldn't have to be only something that Mars has. It could be that Mars has the intellectual capital, that is the people who went to Mars are of a particular variety of people who have certain inventive ways that then create a resource that other people want. Look at Switzerland. Okay, Switzerland's in the mountains. All right, it's like what do they have? So they took their natural resource and made stuff. They pioneered chocolate and clocks and the Swiss Army knife. The top three. No, there's just they made precision timekeeping an art, and so the Swiss watch wasn't just a sales tag; it was a real thing. And you don't mine watches out of the mountains. This is an expertise that your culture brings that you then put into commerce. So I can imagine if we were a multi-planet species, that not everybody's going to be building the same stuff. And so whether or not there's a natural resource that you would trade as natural ore, which surely would still happen, it could be that you got people who like making one thing versus another, and you need it on another planet. So then you'd have this interplanetary commerce, which would be great. I look forward to that.
Very cool.
And by the way, asteroids, like you incorrectly had remembered, asteroids from the asteroid belt, if you get a metallic asteroid, that is a concentration of all the heavy elements that we've cared about in our civilization: cadmium, platinum, gold, what else? Just name any all the rare earth elements, yttrium.
Right.
All of these are in high supply in these asteroids. So it might be whoever gets to lasso the asteroids best, then their commerce is not only what they do on their planet, but their ability to exploit the resources of space, of wandering objects within space itself. So yeah, that's a future of, what did they call it before they invented capitalism? A mercantilism, interplanetary mercantilism. That's what that is.
Very nice.
Oh, yeah.
Very nice. I love that word, mercantilism. All right.
That's what made Venice and Amsterdam and all
the mercantiles
in the day. The mercantiles, yeah. Merchant of Venice.
Merchants of Venice.
They didn't say capitalist of Venice. They said merchant of Venice. Right.
That's right. Cool.
Shakespeare's play, of course.
All right.
So, all right. What else you got?
Okay. This is Kevin.
By the way, wait. What were these focused into any theme, or is it just any question about anything?
Well, I don't see a theme.
Okay. Okay. All right. Okay. So here's what I'll do. And we discussed this on another episode, where it's not that I know the answer to everything, but I know some things about a lot of things. So if you ask me a question I can't answer, I might give you something to know about that might still not answer your question, but gives you still something to walk away with.
All right. So we'll call this one Cosmic Queries, Something to Know.
Okay. Let's do it.
There you go. Kevin Vivile says this.
Is it Devaille? Is it two L's and an E?
No, it's not a Yardro type deal.
Okay. All right. It's for whom this is their first Cosmic Queries. Chuck don't know how to pronounce anybody's name.
No, I do not. I do not know how to pronounce anyone's name. And by the way, when I mispronounce your name, the great thing is you now have a new name. You can hide from the government.
Chuck will baptize you with a new name.
That's right. I'm giving you a new name. This is the beauty of being on StarTalk. Okay?
All right. Okay.
So Kevin wants to know this. Why is our galaxy in the shape of a spiral? And why do other galaxies have other shapes?
Okay.
What determines the shape of a galaxy?
Most galaxies in the universe are spiral galaxies.
Oh.
So we're in the club. Okay. We are not rare in this, first of all. Second, so the two main things, that's a great question, by the way, an observant question. All right. Because some galaxies are kind of elliptically shaped and others are sort of flat spirals. So we call the elliptically shaped galaxies elliptical galaxies. And we call the spiral shaped galaxies spiral galaxies. All right. Because that's how we roll as astrophysicists.
Astrophysicists are too busy doing math to come up with inventive names for stuff.
We just call it
they just call it what it is. Oh, look at that. It's a cigar galaxy.
That's what it is. That's what we do.
Oh, my goodness.
Region of space, you fall in, you don't come out. Black hole, okay? Like black origin of space-time, Big Bang, right? We fully embrace one-syllable communication with each other, okay?
About an economy of words.
Jupiter has a big red spot on its surface.
Right.
You know what we call it?
What?
Jupiter's red spot.
There you go.
Wait, that's not the only spot, right? The sun has spots.
And we call them?
Sunspots, okay?
Oh, yeah.
Okay.
Look at that. And now back to this equation. What should we call this? Neil, what should we call this? It's spots on the sun. How are sunspots, man? Back to this equation. Back to this equation. So what determines the shape of a galaxy?
Okay, so watch. So you have this huge gas cloud and it begins to collapse. All right. And because gravity, that's the natural thing gravity wants to do. I'm talking about a gas cloud larger than a galaxy that will become a galaxy. All right. If the galaxy has any kind of extra spin to it, as it collapses, it spins faster. Mm-hmm. Okay. You've seen this on ice, where ice skaters, right? If they're spinning at all, if they bring in their hands, they end up spinning faster.
Right.
There's a basic feature of physics It's called the conservation of angular momentum, but that's what happens. If you shrink down, you spin faster. If I weren't in a chair, I would do it physically. The next time we'd have StarTalk Live, I'll do it StarTalk Live. In fact, we did it in one of the StarTalk Live when we had, we had an ice skater on one of our guests.
Oh my God. And I know her well. Oh,
right.
God,
so, but anyhow,
go ahead.
So if you're one of these higher spinning, faster spinning, as it begins to shrink, it spins faster and faster. And as it spins faster, that part of the galaxy has a harder time making it into the middle, whereas the top and bottom just falls in. So you get a nice big bulge in the middle, but the rest flattens to make this disc. Okay, it's what happens when you spin pizza dough. It flattens. Okay, right. And so if you took Pillsbury Doughboy, right, and started spinning him, he'd flatten. Okay,
wow,
hazardous activity for
exactly
if you were not a solid shape.
And if you throw some chocolate chips on him and put them in the oven,
that's worse. So anyhow, so that's what, now these galaxies have a lot of gas in them, and it's gas out of which you make stars. Okay, stars are gas, and so you have all this gas, and here's what happens. We think that there is a shock wave within the rotating system that compresses the gas, and where that gas compresses, you make extra stars. So the spiral structure of a galaxy is where extra new stars are being made. And so it's the stellar nurseries that trace the spiral pattern. There's still stars everywhere else. All right, if you look carefully at spiral galaxies, there's stars everywhere. But along these spiral edges, that's where you get very high mass, high star formation activity. And galaxies that don't rotate much at all, they don't flatten out. And they forever stay as these spherical elliptical shapes. And they're not making many stars today. You're not going to find exploding stars there, which is the sign of newly formed stars that have high mass that become supernova and black holes and all the cool stuff. So we live in a really cool galaxy because we have a lot of stuff going on.
Nice.
So,
cool. By the way, her name is Sasha Cohen.
That's Sasha Cohen. Yes.
Sasha Cohen.
Exactly. Thanks for remembering that. Yeah.
Very cool. Very cool. I love that. All right.
So were you first asking Patreon questions?
No, I was not. So
okay. So in a normal Cosmic Queries, the whole first section is occupied by Patreon questions. Plus, like I said, they get their own exclusive posting.
That's right.
Yeah,
their own Cosmic Queries, a command performance where you get to ask whatever you want to Neil. And that happens once a month if you are a Patreon patron. So go to patreon.com/StarTalk Radio and support us right now. And then if you're $10 and above, then we could do this privately for you, just for you.
Yeah.
Yep. All right, here we go. This is why don't we take a live question? All right.
Wait, and just to be clear, people are watching this on YouTube, right?
Yes, they are.
So I just want to remind people this million plaque. So thank you all for having done that. And if you haven't done it yet, what's stopping you? I'm just asking.
Right. If you haven't subscribed yet, right. Now's the time.
Now's the time.
Now's the time. If not now, when? Right.
And if not, who? You.
There you go. If not now, when? And if not, who? You.
Right.
There you go.
All right.
This is, let's go to live from our YouTube chat room. And this is Isra Gashi. Sorry, Isra, if that's not right.
It is right, according to Chuck.
There you go.
In the Chuckiverse, it's correct.
There you go. I like that. Isra says this: if light has no mass, why is it affected by gravity?
That's a brilliant question. And because, gravity attracts mass, right? And so if you got no mass, why should you care?
Right.
Okay. Because according to, there are a couple of ways out of that one, but let me give you the cleanest. The cleanest explanation is gravity is not a force on a mass. Gravity is the distortion in the fabric of space and time caused by any
Right.
concentration of mass and energy.
Uh-huh.
And so if you are moving through space, you are moving on a path that your speed plus the curvature of space requires of you. And so if you're matter moving substantially less than the speed of light, you will curve in towards the object. If you're moving the speed of light, you will follow the pure curvature of space-time itself.
Wow.
As distorted by the effects of any kind of concentration of mass. So light, we say the light bends, but if you are the light, you think you're going in a straight line.
Oh, wow. That
right?
is so cool.
So if you look along this direction, even if it curves down like that, it'll appear to you as that thing down here is right in front of you, because you are traveling the shortest distance between those 2 points, and it's a straight line to you. Step back and you see the curvature in the fabric of space. So there you have it. Another way to think about it is E equals mc squared, energy and mass, and c squared is the speed of light. So energy and mass are equivalent. If you drive an electric car, let's say a Tesla, and then you fill it up by charging the batteries, your car weighs slightly more for having charged batteries given the energy that you put into the car than it did before you put in the energy. Okay, so that's the E equals mc squared equation. So you can convert the energy of the photon into a mass and then treat it as though it had that mass, and then follow the equations thenceforth. So there you have it. That's why.
That's pretty wild.
Yeah.
That's so cool. So that's why when you look at a black hole, you see the light around the black hole, but that's not light from the black hole.
Not quite. It's light that was behind it that got curved.
Curved
my head
around.
is the black hole, and the light here came up and around, and then it came out the other side, and you're over here watching it, and you saw something on the other side of the black hole, and that works in all directions around the black hole. So in that famous photo of the black hole that made headlines several months back, what you saw is light surrounding the black hole having come around it. So you see the shadow of the black hole.
Sweet.
In a sense. Yeah.
Very, very cool. Okay.
That's light. So that's light being affected by the force of gravity.
Nice.
Oh, yeah. Mm-hmm.
All right. Okay. Lucid Potato.
Okay.
Okay, Lucid Potato wants to know, what are your thoughts on NASA's recent remarks on the possibility of parallel universes? I'd ask a lot of questions if I could, but this has been bugging me since I don't trust news articles.
Oh, okay. So there was an experiment conducted where they're looking for particles from space. These are called cosmic rays. They're called rays, but they're actually high energy particles, and they collide with the atmosphere, and they make a stream of other particles, and you can measure them. And we've been doing this for since back in since the early 19th century. Okay, so these particles are coming through. Well, okay, this apparatus that's measuring these particles found a particle come from the opposite direction. Okay,
right.
They didn't expect that.
Yeah.
One interpretation is that this particle is in fact from another universe where time moves backwards, and you're watching this particle travel backwards through time.
Okay.
So it had already passed you, but you're seeing it move backwards through the other direction. Okay. Or there was a glitch in their apparatus. Okay. I mean,
there you go.
There's 99 explanations you can put into this before you're compelled to have to say this is a parallel universe where time moves backwards and that particle happens to be detected. That's all I'm saying. So what makes headlines is the one that gets the click. That's the clickbait. Okay, if there's probably something wrong with the apparatus, or they made a mistake, or whatever, that doesn't get the clicks. So I think on that level, what's the person's name? What's his name?
Lucid Potato.
On that level, Mr. Potato, you are you should be skeptical of the magnitude of news headlines when they are reporting a scientific result. In almost every case, if you read the original scientific paper and look at how they couched the explanations, it will have nowhere near the hyperbole of how the newspaper article was written, because scientists are trained to be conservative in our estimates. So,
yeah, but like you said, that is not a very good news story. Could be a parallel universe, probably a malfunctioning piece of equipment.
I mean, I'm just, there's a ranking of things. If you can have an extraordinary explanation for something, you better have extraordinary confidence that the whole supply chain of your experiment was working. That's all.
All right, cool. I see here in the chat that okay, Rish.
You got another one?
Rishab.
Okay.
Rishab says this. It's a really cool question. How is the universe 92 billion light years across when the Big Bang happened only 14 billion years ago? Wow.
So,
whoa.
Okay, so let me put some context in that 92 billion light years across.
Okay.
So you cannot see 45 billion light years in one direction or the other, right? That would be 45 billion that way, 45 billion that way.
Right.
This plus this equals to get you to 90 or 46, right? So no, you can't see that because their light has not reached you yet, okay? We calculate that as the current size of the universe based on the rate of expansion from the Big Bang, okay? So what's the farthest you can see? The farthest you can see is 14 billion light years away, okay? That galaxy that's giving you light, well, 13, the universe is 14 billion years old. The first galaxy light is like a 12 billion, but for the answer to this question, that distinction doesn't matter. Put a galaxy at 12, 13 billion light years away. We are seeing that galaxy being born. That its light is now just reaching us. Okay? All right. Right now, in this instant, that galaxy is 45 billion light years away. In this instant, if you could see everything all at once, that's where that galaxy is. That's why you would say the diameter of the universe is 92 billion light years across. Mm-hmm. So the horizon is smaller than that. That's how you get those two numbers.
Okay. All right. And okay. That makes sense. So, but I think what he or she, I can't, what he's also saying is if light is time, like the passage of time in order for a light year, you're talking about time as well, mm-hmm. Then how did you get so many more light years in the totality, even though you're only seeing the horizon?
So what you see is not all that's out there. That's my only point.
There you go.
So it'd be what would be a good example of that? Let's say a turtle had a message on its back.
Okay.
Said the universe just began. Okay, and you put it in St. Louis and have it walk towards New York. Okay.
Okay.
It'll be a long while before that happens.
About 45 billion years.
No. It'll take the turtle 13 billion years to get to you.
Right.
Okay. But what has happened to St. Louis? That it's expanding beyond that horizon. It is, and you put in the model, the expansion of the universe.
Right.
Puts far beyond.
And that's really where that's really what he.
By the way, the model could have been different,
right.
And it could have been even farther than that.
Exactly.
But we have modeled the expansion of the universe, and that's where you have it.
So it's not about the 14.8 billion light years. It's about the expansion of the universe.
Yes,
that's really what it's about. Cool.
You got it.
And is that model and also?
Well, it's modeled just by the rate of the expansion of the universe. You see how fast it was expanding early on. Right. And then a little later and a little. So you look at that expansion rate between then and now.
Gotcha.
I mean, light
Wow.
is still doing its own thing, but what is the So, in other words, the moment that galaxy emitted the light from 13 billion years ago, the light is en route.
Right.
Okay. And it is decoupled from what the rest of the universe is doing.
It's a mobile post office. They put the letter is on the way, but the post office is still headed off. Yeah, that's kind of cool.
Exactly.
Right.
There you go.
That's it. All right. There you go. All right. Let's go to
let's go into like soundbite mode.
Samiran. Oh, are we running out of time?
In a few minutes. No, but I just want to get back into that rhythm.
All right, let's get back in the rhythm. Samiran says this, congratulations, coming to us from YouTube. Congratulations, Dr. Tyson, on 1 million subscribers. Hey, Chuck, when the James Webb Telescope is finally in orbit and operational, what kind of discoveries will it expect to make, and which discovery are you most excited for?
Okay, excellent. So a false assumption was made that it would just be in orbit like the Hubble telescope. This is going to be 1 million miles on the other side of the moon.
Wow.
Now, it will be orbiting the Earth, but in a way that is out at that distance, okay? So it's not like astronauts. If something goes wrong with that telescope, ain't nobody going to fix it.
Wow.
Okay, it's not going to be serviced. It's not going to have hero astronauts replacing the lenses or the detectors or the computer chips.
No Bruce Willis.
Well, saving us from an asteroid, I presume, is your reference there. So, so that telescope, here you go. You ready? Newly born galaxies, 13 billion years ago, okay, had emitted a lot of, most of the energy was high energy light emitted by these galaxies, mostly from the birth of brand new high mass stars. A lot of blue light is coming from them. However, that light has been moving through an expanding universe, and that light has redshifted. It has become lower energy light. So it's shifted from blue to go backwards through it. So it's, what is it? Green, and then orange, and yellow, green, and then red, and then infrared. You go through the whole spectrum. It has shifted so much that the principal light from those galaxies is now in the infrared part of the spectrum. This telescope was conceived and designed to observe redshifted light from galaxies born at the beginning of the universe.
Ooh.
It is brilliant.
Wow,
Brilliant.
that is really brilliant. So it's almost like a little visual time machine to go back and look at the near beginnings.
And because you see, originally we were just discovering stuff with our normal optical telescopes, and it's like, okay, is it there or is it not? I don't know. What am I looking at? Let me decode it. Now we know what that light would look like, even though we have no data. If there are galaxies being born, this telescope will see them in the infrared because we know what galaxies would look like being born. So it is the invocation of very deep understanding of the history of the universe and the formation of stars and the formation of galaxies to have the audacity to build a telescope just to sneak in and observe that in the way no other telescope has done before.
Wow.
Now, because it's sensitive to infrared, it can also look deep into gas clouds that are nearby, because infrared penetrates gas clouds in the way visible light does not. And so you can look and see stellar nurseries, stars being born, planets taking shape in the disks around the stars being formed. So it'll be hugely useful for nearby gas clouds as well as the origin of the universe itself. James Webb Space Telescope. Can't wait.
Yeah, that's pretty exciting. And it will also be able to see Predator. So
what?
All right, nothing.
Oh, because Predator sees an infrared.
It's in the infrared.
Man,
see what I did there? Okay.
I had to like, okay.
Yeah, it was
Predator the movie.
It was a walk around the block, man.
That was a total walk around 3 blocks.
That was a walk around the block. Okay.
Predator the movie,
right,
was an alien who happens to be about the same size as humans and walks on 2 legs, has 2 arms and a head and eyes, nose, and mouth. But he's from outer space. Don't get me started. And Arnold, and others.
Yes.
You make fun of Arnold. You make fun of Arnold Schwarzenegger. Okay, English is not his first language. If he speaks, however much you make fun of him, he speaks English better than you have ever spoken German.
Well, this is true,
okay,
I'm sure he could pronounce these names. Jack, I can pronounce the names better than you. Okay, listen to me, Jack. You screw up the names all the time. I pronounce it better than you. Okay, so I'm sure.
Anyway, so he starred in the movie. We had some other sort of muscled soldier types with very powerful guns, and it's they against Predator. And Predator, you got to see what Predator saw, and Predator saw in very low res infrared images. Yep. We have detectors that have way better resolution than Predator saw when you saw just this sort of glowing heat source moving in front of them.
There you go. All right. Okay, here we go. Back to, okay. I love this question from Extra Crispy Colonel. He says this: how plausible do you think the idea that it is possible for light to reach around the universe and reach us again? For example, I've heard on the show from people like Jan 11 that it is possible that some distant galaxies might be our galaxies billions of years ago. The light is just reaching us again.
Yeah. So you need a different kind of geometry of the universe. What's his person? Mr. Crispy, what is his
Extra
name?
Crispy Colonel.
Colonel. Okay, Mr. Colonel.
Mr. Colonel.
It needs a different kind of geometry. So the point is, there exists a geometry where the light will go out from our universe, curve in the curved fabric of the entire universe, come back, and then you can see that light from this direction, and it would be our own galaxy. But the shape of our universe is not one that allows that. But people have posed that question and attempted to answer that by looking at the birthday photo of the universe. This is the famous cosmic microwave background, the CMB. It is a background of microwave light. So here's another redshift thing. That light started out as visible light, like the surface of the sun. Is very rich in visible light. And over the expansion of the universe, it has redshifted way through, came out the other side, went down through the infrared, and it landed in microwaves. That's how redshifted it got.
Wow.
And so that is a record of the structure of the universe when that light was released. That's when the universe was about 380,000 years old. That's a baby picture right there, all right, relative to the 14 billion year age of the universe that we have today. So there exists shapes of the universe where that could happen. But we're not in one of them. But that would be a fun, interesting universe.
Yeah, that's very cool.
Chuck, was it one of our other cosmic queries? It might have been a Patreon cosmic query where someone suggested, can we set up a sequence of mirrors in space? Right. And so you can see our past, and there's nothing preventing that. So if there was a perfect mirror 33 million light years away, okay?
Okay.
And we took out our telescopes and looked at that mirror, we would see Earth from how long ago?
33 million years.
No.
Wait, 33 million light years away?
Yes.
We'd see Earth now?
No. Check.
Wait, what am I missing?
Check. Don't make me go in there and slap you. Okay. So there's a mirror 33 million light years away. Okay.
Oh, 66.
Thank you.
Yeah, I'm sorry.
Thank you.
I forgot about the mirror.
It's a mirror.
I forgot the mirror. We're looking in the mirror. I missed that part. I missed the mirror.
All right. So it goes out there and it comes back. So the light that we see now is light that left Earth 66 million years ago. Okay. And that's just on the cusp of when the dinosaurs were taken out by an asteroid and possibly other natural forces on Earth, like super volcanoes. So if you had a series of mirrors, you could, in principle, see the history of the Earth.
You could see your own past.
Yeah.
That's
You have to
pretty cool.
pre-set those up and then get back here. That's part of the problem.
Well, yeah. We'll work that part out,
Right. So no, think about it. If you put a mirror 33 million light years away, you have to travel there at the speed of light. We wait for you. You come back 66 million years later. Now you'll only see what Earth looked like when you left, not in our past, because you can't see into the past of when you first put up the mirror.
And this is
unless you can travel faster than light.
Right.
And wormhole will allow that, by the way. I can't wait till we have wormholes. Really.
Right. Yeah. Well, this is why we have to shore up Social Security.
What is that?
So when you get back, it'll still be here for you. All right. Okay. Here we go. How about this one? I like this question.
How are we doing on time? What
God, man.
Got a few minutes. Okay, keep going. Keep going. I said I'd give soundbite answers, and I haven't been.
I don't care. They're good answers.
Okay.
I don't like your soundbite answers. I'm going to be honest. I mean,
Let's try one. Try one. Let's try one.
All right. Here we go for a soundbite. This is Cesar Reese who wants to know this. If the universe is expanding and galaxies are moving away from each other, how come the Milky Way will collide with Andromeda? Shouldn't they be moving farther away from one another?
Galaxies that are near each other have speeds that are greater than the expansion speed of the universe at those close distances. So their orbital speeds override the expansion of the universe. And that's true for our solar system. Mm-hmm. It's true for nearby galaxies that are nearby each other. That's why we have galaxies colliding all across the universe. These are galaxies that already started nearby each other. Now, I got to break soundbite mode and give you something that will prevent you from having restful sleep this evening.
Here we go.
Okay. You've heard of dark energy.
Yes.
So dark energy is a pressure in the vacuum of space causing an acceleration of the expansion.
Right.
That acceleration is, if it is caused by a pressure in the vacuum, then the more vacuum you have, that is, the more the universe expands, then the more of this dark energy you have relative to gravity, because gravity is thinning. Okay, as things get farther out, gravity gets thinner and thinner, and if you live in the vacuum of space as dark energy, you win. And you not only beat gravity, your rate of expansion becomes exponential.
Oh,
a word we've heard a lot about in the coronavirus. Okay, I've got my containment vessel here, okay, of coronavirus. But, okay, so calculations show that in 10 to the 22 years from now, okay, the expansion, the accelerated expansion will be so severe that we'll have what's called the Big Rip.
Oh, yeah, that happened to me once on stage. It was terrible. Oh, my God, it was so embarrassing. And, you got to go on with the show, man. You can't just, you can't just say, I'm sorry, guys, I got to give me 5 minutes.
So it reaches a point where even the gravitational attraction of the planets and their moons and the planets and the host star and in a galaxy and nearby galaxies, even those will not be able to stay together. And galaxies that would have collided would get ripped apart. Then it starts stripping planets from their host solar systems, their star systems. Then it begins ripping matter apart. Okay, this is the Big Rip, and this accelerates. Okay, so the scenario I'm describing happens fast after you've waited that much time, because the power of this rip, okay, manifests on large scales first. And then it's happening so much that the very fabric of space itself feels it even on the small scales. And so it starts ripping apart solar systems, ripping apart matter. Then it rips apart atoms. Then
game over, dude.
Game over. And then it might even rip apart the particles themselves.
Oh, that's just terrible.
The Big Rip. So this person wants two galaxies to spread apart. Be careful what you wish for.
Wow, Cesar. There you go, buddy. You opened a whole can of galaxies, didn't you? Holy moly. By the way, that's a really depressing thought. Because
just think about it. Just imagine that beginning to happen around you. Oh my gosh. Yeah.
Dude, that's the Thanos snap. It's like everything just that's just terrible. That's terrible.
Yeah.
Okay, here we go.
But Thanos saved some people. He didn't do that to everybody.
That's true. Yeah. But see, the universe doesn't even have as much compassion as Thanos. Damn, universe. Damn, universe is cold. You cold.
Universe. Ooh.
Absolute zero cold. Hey, okay, here we go. This is Hunter Coleman who wants to know this.
Wait, that was beautifully geeky. Chuck, what? I just want you to say. Because in the hood, you say, that's cold.
That's cold.
Insult you. And then you say, yeah, that's so cold. That's absolute zero cold.
Yeah. That's oh my God. Okay.
No, you can write a whole play on like really geeky street hoods.
Yeah, that's so cool. Call it blurs.
Blurs, yeah,
black nerds.
Black nerds.
That's right. So cool.
In fact, I think Saturday Night Live had a skit about that.
About black nerds?
Yeah, in the street. They're hanging out on the street.
And I did not know that. Oh, yeah. I might have to look that up.
Check that out. All right.
And you know what's funny? The one time in life when I'm home to watch Saturday Night Live, because I'm not allowed to go out, because I'm never home on Saturday nights.
Right.
I'm always working. And there's no Saturday Night Live.
All right.
All right, here
we
go.
Had a few coronavirus episodes.
Okay. Yeah. All right. Hunter Coleman wants to know this. Could the fourth dimension be holding together the fabric of space, the one that we just talked about ripping all apart? For instance, in our 2D dimension being stuck on a flat surface that our 3D world makes up and holds together, is space the flat surface for us?
Yeah, it could be, but I don't think it requires higher dimensions to contain us. It could just be that our life in 3 spatial dimensions, 1 time dimension, is the flat surface for the 5, 6, 7 dimensional beings.
But totally. Doesn't necessitate that is
that contains us,
holding us.
Right. And I would say they would pity us for living in a mere 4 dimensions.
Wow.
As we would pity anyone that exists only drawn in a sheet of paper in 2D.
Yeah. That's so true.
Yeah. All right, keep going. Lightning round, 5 minutes. Go.
Here we go. Nebula Man 60,007 says, would it be possible to make your own man-made wormhole? Is it ever possible?
Yeah. So we know how to make a wormhole.
Ooh.
No, sorry. We know the mathematics of.
Okay. Sorry. You got me really excited. I was like,
no. It's like, oops! Did I just?
No. You gave up the tapes, Neil. It's too late. Too late.
No, we don't know how to make a manhole. No, I promise. I mean, a wormhole. I promise we don't know how. But on paper, we can describe it. But it turns out to configure matter and energy to open the hole makes a very unstable conduit. And so we don't know how to keep it propped open so that if you step in it, then it would collapse around you, and no telling what that looks like if it collapses around you. So,
there you go.
And I have to tell this, I've said this probably the 5th time I've said it on StarTalk. I was in Charlotte Airport and going from a big plane to a little plane. I swear it was 3 miles to walk that distance. And this is early in the days of Twitter. And I thought I was cute. I tweeted about that. And I said, I can't wait for when we have wormholes, that when all gates are adjacent to one another. That'd be an awesome airport, right? You just sort of step and then you're there. Right. And then someone replied, Dr. Tyson, if we have wormholes, you don't need airports.
Oh! But the wormhole is the airport. See?
Yeah, that's what I'm saying. Yeah. All right,
here we go.
Keep going. A couple more.
Here we go. This is Raman Sage who wants to know this. How recent is the information our telescope's giving us about anything up there? Since the light is a lot in the past, how are X-ray and other telescopes or even radio signals doing in this context of bringing us information?
Yeah, so we speak of things in the present just because it's easier. In the same way you speak of the sun rising, even though Earth is rotating such that the sun comes in view above your local horizon, it's easier to say the sun rose, okay? In astrophysics, it's easier to say, oh, we observed the star blow up yesterday, or this thing happened 2 days ago. Well, it happened way longer ago than that, and the light is just reaching us. It just becomes very clumsy to say that. We have no way of knowing anything in the present moment because it takes light time to reach us. You can't even know what the sun is doing right now. If Thanos came in and removed the sun, we would still be in orbit around the sun. You'd still feel the sun's rays. Everything would be the same for 8 minutes and 20 seconds. You would have no idea there was no sun there. So we see things not as they are, but as they once were. And the farther away it is, the more ago it once was.
Wow.
And we're just stuck with that. So in a way, everything we see in the universe is kind of like a ghost.
It's all yesterday's news.
And in fact, there's an Italian movie called La Corrispondenza.
La Corrispondenza.
The correspondence. Jeremy Irons starred in it as an astrophysicist.
Okay.
And he had a terminal illness, and he had a love interest, and he would send her letters, okay? But she didn't know he was dying, and I think it was overseas or whatever. But he would send her letters so that after he died, she would still get letters. Like stars that might have died long ago, but still send you their love.
It's kind of cruel, man.
It was an astrophysics love story.
Yeah, like I said, it's kind of cruel.
All right.
All right, one more. How about this one?
One more, okay.
Archer 123,000 says this. Do you believe in life on other planets?
Yes, it's not about belief. Is there evidence? There's no evidence yet. What are we made of? Life on Earth, the most common ingredients in the universe is what life is made of. And I've said before, if we were made of like some isotope of bismuth, you would have good argument to say, hey, life is special. Well, life is rare. We're made of hydrogen, oxygen, carbon, nitrogen. This stuff is the top 4 ingredients in the entire universe. So as we look for life, just because we haven't found it yet, absence of evidence is not evidence of absence. Okay? So, and by the way, how much of the universe have we looked? I quote Jill Tarter from the SETI Institute. Jill Tarter says, based on how much we've looked in the universe for life so far, to declare that there's no life would be like going to the ocean with a cup of water, with an empty glass, and you scoop up some water and look at it and say, oh, there's no whales in the ocean. Or no fish at all, right? No
fish at all.
That's how much of the ocean you've looked at by scooping up a glass. That's how much of what we call parameter space of life in our galaxy that we have studied, that we have observed. So restricted by time, restricted by frequency, all these factors combined is like dipping a cup in the ocean. So just because we haven't found it doesn't mean every one of my people, astrophysicists, have very high confidence to look for it on the expectation that one day we will find it. The real test is, and the scary and tantalizing part is, could there be intelligent life out there? And if there is it more intelligent than we are? Would we even know it if we found it? Because as we've said, one thing is for sure, there is no sign of intelligent life on Earth.
Chuck,
I think we got to stop it there.
Yeah, damn, that's a shame. This was fun.
Yeah. And just a couple of things, since this is live, I might as well say next Tuesday, we post the next episode of StarTalk Sports Edition. Yeah. And that's where I interview Sophia, the AI robot.
Yes.
That's Sophia. She's got like facial expressions, a little creepy.
Yeah.
She talks and you know.
Yeah, I like them creepy though. So. No, sorry. That one was not the sports edition. That's just regular. That's regular. Sorry.
We're talking about what role AI would play, artificial intelligence would play in helping us understand the coronavirus. Because what good is AI unless it could be our servant?
Right.
It can help us. So,
yeah.
But she's so real. It's like, no, you don't want to be a servant. You want to be like one of us. All right. And so it's really creepy, weird, fun, interesting, tantalizing. So that's next Tuesday on regular Star Talk. And every other Friday, we release the sports edition. So check it out. If you're a sports fan at all, I think you'll love it. And so there it is.
Cool.
So we've done it again. Thank you all for this plaque. Thank you, YouTube.
1 million. down.
Let me rip off the plastic. Yeah, it's gold.
Look at that.
Oh yeah, mined from an asteroid. They told me. Ooh, I just put fingerprints on it.
Yeah,
that's nasty.
That's very cool, though.
Yeah. All right. So thank you all. And if you haven't subscribed, there's a button on there somewhere, I'm sure. You can join us. But
a button somewhere.
somewhere
somewhere in your house. There's a button.
Push it
and subscribe to this show.
All right. And again, we welcome any and all Patreon members. You're part of our lifeblood. So Chuck, always good to have you.
Always a pleasure, Neil. And yeah.
And I know we couldn't get to all of the 1,000 questions, of course, but that's how this goes.
Well, that means we have to do it again.
All right.
There you go.
All right, Chuck. I'm Neil deGrasse Tyson, your personal astrophysicist. As always, bidding you, especially in the coronavirus, to keep looking up. Signing off.